I think you use a compass to draw circles. Protractors are for measuring angles, because they measure angular. I hope you all got that like a couple of years ago. All right, I just blew some minds, so let's give a talk. So my name's Julie. I'm a software engineer in tools and infrastructure at Google. I work out of the Seattle office, and for the past couple of years, I've been working with the Angular team on testing framework, mostly Protractor, but I've also been working a lot recently with unit testing frameworks for Angular 2. So I'm going to talk about testing your tasks, or as I like to call it, the return of the zones. So, if you were here 2 years ago or watched the live stream or the recordings, you may have heard Brian Ford give a talk about this library, this mysterious library called zone.js. And zone.js, as he mentioned, is for managing asynchronous tasks. It's a way of controlling execution contexts for JavaScript. So why am I here talking about zones again? And here's a link to the original talk that'll be in the slide deck if you haven't seen that, which is great. There have been a couple of changes in the past 2 years. First, zones is not theoretical anymore. It's actually in use in Angular 2 for really important behavior, which I'll talk about. Secondly, we've undergone a major refactoring for zones, which introduces a new API and a couple of new concepts. And finally, I find asynchronous behavior in JavaScript confusing, which I think a lot of people can relate with. And I think that these concepts are often worth revisiting, even if you've heard about them before. So, zones track and control asynchronous activity throughout your application. What does that actually mean? First, let's take a little reminder of what's going on in JavaScript when we use asynchronous activity. So your program has a call stack, which is synchronously running all of your functions, popping them in and off of the call stack. And when that's all done processing, you've probably asked for something like an XHR. And the event loop is a management that will call back into your code when that callback queue is done. So after your set timeout is finished, it'll pop onto the callback queue. The event loop will take the first thing in that queue, run any of your actual code that needs to be run, and then get the next thing off the queue or wait for something to be scheduled. And there's one more piece here that I've drawn in, which is the microtask queue. And this is a browser spec, and microtasks will run after your call stack completes, but before a turn of the event loop. The most common time that you'll see these is in promise callbacks. Those should always be queued into the microtask queue so that if your promise is already resolved, it'll still run asynchronously, so your behavior is consistent, but it'll run immediately and save up time for the browser processing. In modern web applications, there's a lot of different things that can make our apps asynchronous, from promises to sockets, event listeners on the DOM, timeouts, XHRs. If we're using Node, we'll have things like file system requests. And so while you might be able to handle, if you have one function, you can use a callback to use the same context for your code and the handler. But for everything that can go on, this becomes difficult. And this is where zones come in. Zones are kind of a big monkey patch over all of this possible asynchronous stuff. And they give you a simple API so that you can hook in to various points of this event loop and modify what's happening or track what's happening. Let's look at how we would actually use zones. So as I mentioned, zones is a library. It's a standalone library that does not depend on Angular. It's available on GitHub or NPM, and so we could install it and just include it in our code with a script tag. And then in our actual application, we'll have this zone global added to the window, and we create a new zone with the fork function. And that's a really simple one. Let's make one here that just has a name. Then, to actually use the zone, we need to run something inside of it. So let's add an event listener for a click handler onto a button inside of our zone. Then elsewhere in our application, we would design that click handler. And let's just log the current name of the zone. And if the click came from that handler, across asynchronous execution, we'll have the same zone name stored. So that's what we mean by zone tracking asynchronous activity across an execution context. So as I mentioned, you create new zones by forking them. Zones form a hierarchy. So Every zone that you fork will be a child of its parents, and it'll have a chance to add hooks and modify behavior, and also be able to delegate to its parent zone. We could create multiple zones inside of our application. And we might want to do this if, say, we have an application, and we want to run some special error handling. We want to log something whenever an error occurs. Zones can let us do that. But we also have this help pop-up box that we're importing from some other team, and we don't really want to worry about their errors. We just want their code to run and not bother with ours. So we can use a zone fork for our application and start that up with our special error handling and use a different zone to run the pop-up box, and those two won't interfere. And in code, this would look something like this. We'll fork a zone with the name for our application and an error handler that'll do some special custom logging that we don't want to do for any parts of the application, any of the other parts of our application. And then we'll run that help pop-up in its own zone that's unrelated. Cool, so this is how we use zones. Let's talk a little bit about what they can actually do. We've been passing these names into our zone forks. There's a lot more that we can add here. This is called a specification for the zone, or a zone spec. And the zone spec API is more complicated than this, but looks a little bit like this, where every zone has a name. We can also store arbitrary properties onto our zone, which will be tracked across asynchronous execution. And then we have a whole bunch of handlers for events like forking, handling errors, scheduling and canceling tasks, and managing task queues. I just talked about tasks a whole bunch. It might be a good idea to go back and define what we actually mean by a task. So if we go back to this familiar diagram of our event loop, whenever our call stack does something like set a timeout or send off an XHR, it's adding a potential thing to what I like to professionally call the pending task puddle, which could be added to the callback queue at some point in the future. So we can think of the pending task puddle as holding all of our XHRs and timeouts that at some point will be added to that callback queue, which is also sometimes called a task queue, and handled by our code. So in addition to thinking of asynchronous activity as this event loop, we can think of it as a set of queues. First, there's the microtask queue, which we talked about. Then there's a queue of macro tasks. And I use quotes for queue here because this isn't actually a first in, first out queue. It's more of a set, but it's easier to just use one word. So this will be any event that is scheduled and has a finite time when it will end. Or it could be a periodic event like a set interval. And then there's event task queue, which we don't know exactly when they're going to fire, but whenever the user clicks or scrolls or presses a key, an event task will be fired. And zones lets us hook in to things like when tasks are scheduled, when tasks complete, and when these queues drain. And when the queues drain is especially important because that gives us really useful hooks into knowing when we should be doing certain things with our application, which we'll talk about in a minute. First, I want to link to a couple of more zones examples because I think the best way to get a sense of how these actually work is to play around with them yourself. So the zone repo has a bunch of good examples, and I have a couple of examples that are similar to what I've put in this talk in my ng-conf 2016 repository as well. Okay, so while we're all here at ng-conf, and I promised that Angular was using zones, let's talk about how Angular 2 contributes to zones. And this gets back to a question that Brad alluded to at the very beginning of the day, which is what happened to digest and apply? We don't have to call them anymore, which is great, but how does that actually work? So Angular 2 change detection is run from your application's root component down through all of its children component, updating properties in a single one-directional pass. So that's great, but how do we know when we need to run change detection? The answer, as you may have guessed, is zones. Angular creates an ng zone, or Angular zone, which every Angular application is run inside its own ng zone. And this exports a microtask empty event, and we can listen on that. And that's a cue to your Angular application that we might have to do change detection at this point. Because that means that all of our processing is finished, some sort of asynchronous events might have changed things, and we should go look and see if we need to update our bindings. So we don't have to call apply and digest, because Angular knows about everything asynchronous that might have happened, because zones knows about everything asynchronous that might have happened. As I mentioned, Angular has a zone that it runs your application in. And this is an injectable service, so you can get a hold of this inside your app. And it has a similar API to the zone spec. It's not quite the same, but it lets you hook into things like when the microtask queue is empty, which we use for change detection. You can look at errors. And then there's these two important functions, run and run outside Angular. This lets you enter and exit the Angular zone in your code. Well, why would you want to do that? Let's say that you have a progress meter in your application. So we'll have a template that will just have a binding for the progress. I'll have a button, and when we click the button, we'll kick off this increase progress function. And all that this does is set a timeout every 10 milliseconds until we get to 100, and then call a callback. We can look at what this actually looks like. I'm really sad I had to go after the material team because I'm not good with CSS. But my buttons are flat, so that's good. All right, so we can see here, Angular's updating after every set timeout, every 10 microseconds, progress is going from 1 to 100, and we're also logging it to the console. So this is normally what you want, but maybe you don't want to run change detection after every of those 10 microsecond steps. You want to do something else. You still want the console log, but you don't want Angular to update because that's expensive, and that's going to interfere with our 60 frame per second scrolling. So instead, we can run outside of the Angular zone, and we'll still get the progress updates in our console, but our screen won't refresh. Angular won't run change detection except for the very beginning and the very end. Let's see what that would look like in code. So instead of the go function, the click handler, just running the increased progress, we'll run that outside of the Angular zone by injecting ng-zone and using its methods. And then once we're all done, we've got progress to 100%, we'll go back into the Angular zone and log that we're done. So I'm up here, I usually talk about testing. Let's talk about testing a little bit. We can use zones to really improve our testing experience. And we use zones for both end-to-end and unit testing. I want to talk about end-to-end first because it's actually a simpler situation for the user. A problem that you often have in end-to-end tests is that applications take a while to load and have asynchronous events and loading bars and progress bars and spinners. And you can get race conditions if you don't properly wait for those in your automated scripts that are interacting with your page like a user would. Protractor worked with Angular 1 to create helpers that would automatically do this waiting for you. But we can do even better in Angular 2 because we can use zones, so our waiting logic can be much smarter. So if you're writing a protractor test, before you do anything that tries to interact with the page or get data back from the page, we use Angular's testability API and ask it, is the page stable? Let me know when it is. Behind the scenes, this is roughly implemented as asking the Angular zone when it's stable, and then if it has no pending macro tasks. So unstable roughly means your microtask queue is empty, and then if we have no pending macro tasks, we're good, and we can run our callbacks and continue with our test script. This also allows us the flexibility to fix a problem that we've had with Protractor and Angular 1 for a while, which is applications often have some sort of always persistent timeout. For example, on the ng-conf homepage, there's this nice little carousel that's showing some information, and it's changing every 2 seconds. And a natural way to implement this might be with a set interval, which ticks every 2 seconds and shows us the next carousel image. But if you try to run a protractor tense against this, your application is never going to be stable because you always have some pending task. But you can fix this as a developer by running that sent interval outside of the Angular zone and then re-entering the Angular zone to update the carousel image. And I have a very small demo of this as well. So let's actually refresh the page. I don't know why this is down, so we're not going to look at that. Maybe at the end. All right, let's talk about unit tests. So for unit tests, you're also going to need to manage asynchronous execution at some point, because asynchronous APIs and promises are prevalent in everything that we're doing. There's a couple of techniques that are out there to deal with this. If you've worked with Jasmine or Mocha, you've probably seen these two. The first is to use a done callback. So you would pass done as a parameter into your test function, and then you would have to call it at some point. So this is a couple of problems. First, you have to remember to call it, and second, you have to remember to handle failures nicely. So we're toasting our toast. If anything errors, what will happen here is we'll just get a timeout right now, instead of actually sending the error message on. And that's not really great behavior. It's hard to debug. Another potential solution for dealing with this is then to return a promise from your test and have your test wait for that promise to resolve. But this can also be problematic because it's very easy to forget inner return statements on promises. So in this example here, we would never get to that inner expectation because our outer promise would resolve, and our test wouldn't actually be testing that your toasted bread is delicious. So in Angular, we can help out by using zones. We've written 2 helpers that are available in the Angular testing library called async and fakeAsync, which will help you deal with asynchronous activity in your zones, unsurprisingly. And you use these by importing them and then using them within your Jasmine-style tests. So you would wrap your entire test function, as shown here, inside of that async wrapper. Behind the scenes, these are using zone specs that we've written that are included in the zone.js library, which track when things are added, when tasks are scheduled, and when tasks are emptied out of those task queues. And you could go in and use these yourself if you wanted to. And then each individual test case is run inside one of those test zones. When all of the queues are completed, it takes care of ending the test for you and cleans up the zone so your next test runs in a fresh, clean zone. How would you actually use this? For our example, let's say that we have a simple widget that displays the weather for various zip codes. This is going to use a service called our weather service, which we will give a zip code, and it'll go do some really expensive processing on the back end that's going to take a really long time, and then give us back a number. So in our test, we'll wrap the whole thing in async. We'll also use Angular's injection helper, because weather service is an injected service, to grab an instance of that service. And then inside our test, we can use asynchronous commands to our heart's content and rest assured that they will all complete and these expectations will actually run. And we can do this with components as well. So here, we're also using the asynchronous wrapper. And we're using the test component builder, which is also exported from the library, to get a component fixture. We'll have a weather widget. We'll run a round of change detection at the beginning just to make sure that everything's stable, using the fixture's detect changes method. And then we can add a value to the zip code input, and simulate a click event on the go button. Cool, okay, so our widget's going. It's going to presumably show the temperature in a little while after that weather service finishes. But we have a problem here. The test knows to wait until the application is updated, but we, in the code, actually also need to get a hook to that so that we can run expectations. So something that we can do, which is a cheap trick that we can do here, is we can just set a timeout and say after 200 milliseconds, we'll run another round of change detection and then run our expectations. And this is not a great solution because we're introducing an artificial long timeout, and we might have flakiness. If our weather service takes longer than 200 milliseconds, this unit test will flake occasionally. So we can do better than this. The fixture API now includes a when stable function, which is similar to the one that we talked about for end-to-end testing, that'll let us hook into when our macro tasks and micro tasks are empty. So instead of having a hack with a set timeout, we can just ask the fixture when it's stable and then run our final expectations. And we've done one other thing in this test. At the top, we've asked the fixture to automatically run change detection whenever it thinks that we need to. This is usually a good idea to call immediately in your component tests unless you need precise control of change detection for some reason. All right, the last thing that I want to talk about is the fakeAsync helper. This is useful for when you need precise control of timing to really check that something works in your component. So let's say that we have a component which plays rock, paper, scissors with you. It's going to count down for 3, 2, 1, and then throw rock, paper, or scissors. And so we don't want to just test the beginning state and the very end state. We want to ensure that it's actually running that countdown and changing every second. We can do this with the fakeAsync wrapper. So instead of wrapping our entire test in async, we're wrapping it in fakeAsync. We'll set up our fixture as before, and we'll set up a click event on our start button. And now, since we're using fakeAsync, we get access to this helper method called tick, which simulates moving time forward by the amount that you place in there. So we'll move time forward by 1 second, run change detection again, and assert that our component has updated as expected. And we can do that through to the end of the test. fakeAsync will warn you if at the end of your test you still have anything pending that it knows about. And behind the scenes, this uses zones to actually intercept and not forward on requests to schedule tasks. So fakeAsync is keeping track of its own queues of events and firing them manually and truly synchronously when you call the tick function. All right. For some further reading and to see all of the examples that I put up here live, I have a GitHub repository for ng-conf 2016 zones. There's also several good podcasts and blogs about microtasks and zones that would be really great to read. Thank you so much.